Hello and welcome back to SkillPanther's Cat Talk Through. We are now going to start on question number 8. Question 8. Is this whole big term greater than equal to 1? Now, what is this term? It's x to the power minus 1 minus y to the power minus 1 divided by x to the power minus 2 minus y to the power minus 2. As we know, x to the power minus 1 is nothing but 1 divided by x, and x to the power minus 2 is nothing but x square, 1 divided by x square, with x square in the denominator. It might sound weird when I say x square first followed by 1 divided by x square, but that's actually how your mind thinks of it, or should think of it. If you're trying to force fit the thinking of your mind to how you write things out on paper, it's not a good practice. Because what you can do with paper when you have a hard tool for visualization in front of you is much greater than what you can do when simply thinking without any tool for writing. But you might say that, okay, we have a writing pad, yes, but if you are trained to solve all these questions just by thinking, what happens is you can quickly glance through questions, and as you read them, you will be able to estimate very accurately how much time it is going to take for you to first think about and figure out the methodology of solving the question, and also subsequently how much operational time it will take to actually do the calculations and solve the question. Notice I broke up solving a question into two parts. The second part of actually solving a question and doing the calculations is where pen and paper is most helpful and saves us the most amount of time. However, the methodology part, there is a certain amount of visual aid that can be received using pen and paper, but the same can easily be visualized by you when closing your eyes or even with your eyes open in front of you. You can think about it. Thinking itself is a way of visualization. For example, if I ask you, hey, think of a red cup in front of you of this kind. Just think this was red. And imagine it in front. Now, different people would think of different shades of red. Somebody might change the shape, whatever. But you are still getting some thought that you can think of in front of you. Which is why go by how your head thinks rather than how you would write it down first. So let's solve this question now mentally. Absolutely, we will simplify this term mentally. It's 1 by x minus 1 by y divided by 1 by x square minus 1 by y square. This is how you write it down as well, right? Fine. Now you can visualize the full term. Okay. Now, when I deal with the numerator, 1 by x minus 1 by y, it's y minus x divided by xy. That's it. At the bottom, you are going to get y square minus x square divided by x square y square. So you know the xy in the numerator will get cancelled out and 1xy will remain in the denominator. The remaining two terms are x minus y, y minus x, and at the bottom it is y square minus x square. Now y square minus x square is nothing but y minus x, y plus x. So the top term y minus x will get cancelled out again, leaving 1. So basically it is the inverse of the bottom term, the denominator, the two parts of the denominator. So it becomes xy divided by x plus y. That's it. Is xy divided by x plus y greater than equal to 1? That is the question. Now let's look at the options. Actually, before we even look at the options, why bother? We need to find out what is the condition under which xy divided by x plus y will always be greater than 1. Now, if we just put in 1, right, x equal to 1, y equal to 1, what do we get? 1 divided by 2, half. Okay, this is less than 1. We need to increase. Let's say we increase one of the values to 2. So 1 into 2 divided by 1 plus 2. So that's 2 by 3. Still does not cross 1. Now let's say I increase one of the numbers. Let's say I increase one of the numbers by 3. So 1 into 3 divided by 3 plus 1. Okay. Now you realize no matter what you do, if you keep one of the numbers as 1, no matter what you add, it's going to be less than 1 because there is one additional 1 in the denominator, and anything multiplied by 1 is itself. Okay. So 2 plus 2 and 2 by 2, 4 by 4, that's equal to 1. It's not greater than 1, it's equal to 1. So if we set the values of both x and y as a minimum of 2, then automatically the number I will get will always be greater than and equal to 1. Another way of saying it is basically saying that here, look, beyond x and y equal to 2, the rate of change of xy with change in either x or y is greater than the rate of change in x plus y. Like you could differentiate the top two terms, and for always increasing it has to be greater than 1. You could do differentiation there as well, but to keep it simple, you just need x and y equal to 2. Anything more than that, it's going to be correct. And I see option 2, x and y are positive integers such that each is greater than 2. That's it, done. The question can be answered with the help of statement 2 alone, has to be the right answer. The first one, x plus y greater than 0, it's unnecessary, it's already included and part and parcel of the second statement itself. Now let's move on to the next question. Question 9 and 10 is based on a game. In a game played by two people, there were initially n matchsticks kept on the table. Okay. A move in the game consists of a player removing either one or two matchsticks from the table. The one who takes the last matchstick loses. Okay. So I will take either one or two matchsticks out of any number of matchsticks kept on the table, and my opponent will also then get his or her turn to take one or two matchsticks. Players make moves alternately. The player who will make the first move is A. So whoever makes the first move is called A. The other player is B. So B will make the second move always. Okay. Before we figure out how to play this game, obviously we understand what it is to win and lose. Let's quickly take a look at both the questions to align our thinking. What should we think about? Because at this point we might have to do double duty work by having to think about how A will play the game and about how B will play the game. Basically, in any game, it will be equal to the number of players. You'll have to think from everybody's perspective. Let's see if that's required. The smallest value of n that ensures a win for B is, and the largest value of n that ensures a win for B is. So, both questions require me to understand the game itself, the context itself, from B's point of view. So, what does B have really as a guarantee? And let's think only about B. B always plays second. So, no matter what A does, B can react to it because B will start the game second as well. Now, what can B do? Let's see. A can take one or two matchsticks. B can take one or two matchsticks. If we were to operate only in this and try and find out what is B's control, control is a point that B can always make constant. In any game, any player going second is trying to first neutralize what the other person does or use that same neutralization to actually win. If I can stop you and win at the same time, that's the best option. Now, what do I have the most control over? If A picks one or two, B can pick one or two. So, a total after each round of two can be either 2, 3 in two cases, and 4 in one case. So, it's in one case it can be 2, in one case it can be 4, in two cases it is 3. This is when B picks 1, A picks 2. When B picks 2, A picks 1. The 3 is constant. No matter what A does, B can pick the number of matchsticks required to make it a multiple, to make it exactly 3. So every deduction is going to be that of 3. And I have been told 1 needs to be left over for A. That means after B's turn at some point in time, there needs to be 1 left over. So literally any number, if I keep dividing it, which finally gives a remainder of 1, if I keep subtracting 3 from it, will be a solution by which B can always win. Because no matter what A does, B will simply reduce it to a factor of 3. If there are, let's say, 4 matchsticks, A will take 2, B will take 1, A will take 1, B will take 2. A will always have 1 remaining. Same thing with 7. Any multiple of 3 plus 1 basically. Now let's look at the options given. Yeah. In the question 9, the smallest value of n greater than 5 is of course 7. That ensures a value of win for B. And in 10, largest value of n lesser than 50. Well, that's any multiple of 3 plus 1. So 48 is the largest multiple of 3 here, plus 1, 49. That's option D. That's how B can always win. The key here was to realize this was a question of quotient remainder and divisibility as a function, rather than looking at a game as some random things that have been asked to do. You can reduce every game to a sequence of mathematical moves. Even chess can be played by a computer. And I'm sure you would have heard of the example where this IBM's Deep Blue, one of the most advanced supercomputers to play chess, beat, I think in 1 games out of 3 or 2 games out of 3, Garry Kasparov, world grandmaster in chess and best in the world at that point in time. You know, the wondrous thing here is not the fact that the supercomputer beat the human 2 times out of 3 or 1 times out of 3. At least 1 time out of 3, the human being won. And it wasn't doing the billions of computations that the supercomputer was doing in processing, in finding out all ways of looking at everything, trying to figure out what is millions of moves, calculating each one of them. Garry Kasparov couldn't have been doing millions of moves in his head. He knew which ones were important, which ones were prioritized. Those thoughts, those moves would come first in his head, not the unnecessary ones, which a computer can't possibly replicate. And so when you are thinking through these questions, you need to think like a human being with elegance and try and figure out what is the fundamental threads that are connecting these questions that make the whole thing sensible and rational, subject to constraints, subject to equality signs, and any other information given in the question. And that's really it. Let's move to question number 11. There were X pigeons and Y miners in a cage. So X plus Y, total number of birds, X pigeons and Y miners. One fine morning, P of them escaped to freedom. Okay. So a total of X plus Y birds and P of them escaped. So X plus Y minus P birds are remaining in the cage. If a bird keeper, knowing only that p equal to 7, was able to figure out without looking into the cage that at least one pigeon had escaped, then which of the following does not represent a possible XY pair? Okay. So pigeons are basically X. So we are being told that, hey, figure out a constraint on X and Y. And we have been told that at least one pigeon has escaped. Now, think about it. What is the only condition under which you would have a guarantee that at least one pigeon has escaped? It is when you know that more birds have flown out than the total number of miners there. If the total number of miners is 6 and p equal to 7, you know at least one pigeon has had to escape. At least, it could be more, but at least one pigeons. That's it. So at max, y can be 6. We got given information about y. At maximum, y can be 6. And there is the first option, 10,8 does not represent a possible XY pair. So, and just quickly check, if I am told that p equal to 7, then in the first case, I know at least one mina. In the first case where y equal to 8, 7 birds have escaped. I don't know anything. Oh. So that can't happen. Right? 2, 4 and 6, it's possible. For p equal to 7, I will know at least one pigeon has escaped. In case of 6, for 4, I will know at least 3 pigeons have escaped. For b, I will know at least 5 pigeons has escaped. And there are that many pigeons available as well to escape. If pigeons were only 1 or 2, then you must be hallucinating. How can p be that much? Right? So, okay. Now let's move on to question number 12. The remainder when 2 power 60 is divided by 5 equals, okay. This is another question remainder case. Let's solve it elegantly, right? We just discussed Gary Kasparov and Deep Blue. Let's solve it like a human, not like a computer. 2 to the power 60 is nothing but 2 into 2 into 2 into 2 into 2, right? Let's take 2 divided by 5. It gives a remainder of 2. 4, which is 2 to the power 2, divided by 5 gives a remainder of 4. 8, it gives a remainder of 3. Next power 16, it gives a remainder of 1. Next power 32, okay, it's again giving me a remainder of 2. Next, okay, it's again giving me a remainder of 4. There is a pattern, 2, 4, 3, 1, and then again 2. So after every first number is a 2, every fifth number, if I start from 0, 1, 2, 3, 4 by 2 to the power 4, 2 to the power 5 is again going to be 2. So now I know whatever number I get, okay, 2 to the power 60. So it's basically 4 repeated 15 times. And what do I get at the end of every 2 to the power 4? That's 16. I get a remainder of 1. Simple as that. Every time I get a remainder, that's basically a remainder of 1 60 times, which itself will give you a remainder of 1. Like it's 1 to the power 60, it's 1. That's it. That's the same pattern that is going to be followed. So B, 1. Let me just quickly check it in another way so that we appreciate the elegance of our number system itself. 2 to the power 60 is nothing but 4 to the power 15? 30. 4 to the power 30 is 2 to the power 60. It's basically a divisibility of the exponent or to the power of whatever number is given. So 4 to the power 30, every time a 4 is divided by 5, it gives a remainder of minus 1. Instead of plus 4, I am looking at it as minus 1. It will be one short of something divisible by 5. And this minus 1 remainder will be gotten from every 4, and this is 4 written out 30 times. It will basically give you a remainder of minus 1 30 times, which multiplied, because it's an even number of times multiplied, is going to give you a remainder of plus 1. So again, I know this is 1. You might be wondering why I'm thinking of all these ways of looking at such big numbers. I've summarized all of it. It's really very simple. You heard me say it right. It is that simple. And I've summarized all of it, and we've created the SkillPanther CAT preparation system where we go through all the topics that are there, and we have done extensive research on all the past CAT question papers to almost be able to predict 50-60% of the questions that are going to come and what fundamentals are going to be needed. We've actually made a video about that research as well, so you can check that out. We'll leave a link to it in the description. Okay. Moving on to the next question. Question 13. Mr. X enters a positive integer y in an electronic calculator and then goes on to press the square root button repeatedly. Okay. Let's say I've entered 5 and I keep pressing the square root. Or let's take 9. 9, that's a positive integer y. I press the square root button 3. Again I press the square root button 1.3732 or something like that, right? Whatever. It's going to keep reducing. And what's going to happen is it's going to keep reducing towards 1 and not 0, because square root of 1 is 1. Now you might be thinking, hey, what would happen if I were to input a fractional value into it? 0.25. Then also it's going to start moving upwards, because 0.5 into 0.5, which is higher than is equal to 0.25, and so if square root of 0.25 equal to 0.5. So in both sides, if it's less than 1, it's going to keep moving up towards 1, and if it is greater than 1, it is going to keep moving down towards 1. Here positive integer literally means 1 or greater. So, and it's going to be 2, 3, 4. So it's going to see the display becomes closer to 1. See, the thing is, when I keep reading this out to you, it stays with you as memory as well, of having heard this question being solved in this way. And as I am speaking out my thoughts, you're going to know how to think. You're literally going to remember these words and these thoughts. And if you read out the question to yourself, as I am doing right now, you will be able to trigger these thoughts while writing the CAT as well. So at the laziest bit, just by listening to this, you are actively preparing for CAT. And if you have a good memory, especially for something you have heard before, just imagine if you go through all the past CAT question papers with me explaining like this. Who knows how fast you'll be able to do the actual test. What is the sum of the following series? 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 is question number 14. It's a series sum question. If I look at any term in the series, right, it is the term itself and the number of the term, n equal to 1, n equal to 2. The first term is, the first term, the second term is the second term. There is a number associated to the order of terms. The first term is, n by n into n plus 1. Second term is that, where n is the nth term number basically. Okay, so any term in the series is equal to 1 by n into n plus 1, where n is varying, and n is here given 1 to 100. Okay. So if I can see the pattern, I can quickly simulate it in a small case. Let's take two terms, n equal to 2. So that will end at 1 by 1 into 2 plus 1 by 2 into 3. That's basically equal to 1 by 2 plus 1 by 6. That's equal to 3 by 6 plus 1 by 6, that's equal to 4 by 6, that's equal to 2 by 3. 2 here is n, so it's n divided by n plus 1. Like patterns now, don't you? So the sum is simply going to be n by n plus 1, 100 by 100 by 1 for the longer series, 100 by 100 plus 1. There's always a pattern to every series, that's why they've given it to you. If there is none, it is going to be a long haul slog calculation. The cat is not trying to test your advanced mathematical calculation speed. They're trying to test your aptitude at figuring simple ways of doing seemingly complicated things. So there is usually a certain elegance to the cat question papers, which if you try and do any mock cats of any company, any educational company, they are inelegant. Already it happens that people take a certain question paper, a mock cat series, because everybody takes it. Then they take another one of a competitor because the English is better, supposedly. I have also gone through the cat preparation, right? I actually signed up for a mock cat series of one of these guys way back in 2010, and my biggest problem was the questions were brutish. It's not how CAT question papers are. You can clearly see a difference if you go through CAT question papers and give any of these mock CATs. It's a work of mass production, these mock CATs from tuition centers. Whereas the CAT paper it's more closer to a work of art where elegance has been kept in mind when designing the questions itself. You can see the guys creating the mass paper from the tuition centers are not smart enough to visualize questions in CAT, to visualize questions how they come in CAT, or maybe they are not spending their own time. Maybe they have hired random people to make these questions, or they're just churning out copies of it. Who knows? But the point is, even we have created mock CAT question papers. We have kept in mind to preserve this elegance along all the topics, and you can try out our free mock CAT as well. We've left a link to that in the description as well, and see how we have made it elegant. I have created it personally. If you want to know who I am, you can check out my biography, not biography, rather my CV or profile as an instructor. My name is Saurav Goswami, as it's written here. And I've kept it in mind to preserve the elegance of how actual CAT questions come, instead of trying to replicate weird brute force questions that come in typical mock CATs, right? Okay. Moving on to question number 15. What is the value of 1 by 1 minus x plus 1 by 1 plus x plus 2 by 1 plus x square plus 4 by 1 minus x to the power 8? Okay, sorry, 4 by 1 minus x to the power 4. 1 minus x to the power 4. Okay, as you can clearly see from the first two terms, if we multiply them, we are going to get 1 minus x square in the denominator, right? We just discussed in the previous questions, x plus y by xy. So x 1 plus 1 minus x, so it will be 2 remaining in the numerator, divided by 1 minus x square. So I just got 2 divided by 1 minus x square. The same pattern will now repeat. So this will become 4 by 1 minus x to the power 4. Yeah. 1 minus x to the power 4. Now 4 by 1 minus x to the power 4 plus 4 by 1 minus x to the power 4. Sorry, 4 by 1 plus x to the power 4 plus 4 by 1 minus x to the power 4 taken together will lead to 8 by 1 minus x to the power 8. Simple. It's just continuously multiply, the x's are getting cancelled out and the whole number is left behind. 1, 1, 2, 4, 8. That's the term, and it's 1 minus x, so that became minus x became plus x, so that's, and then x became x square, then x square becomes x4. It's basically getting multiplied by x, or minus x the first time, then plus x, and so on and so forth. Okay. Let's do that again. Question number 15. What is the value of 1 divided by 1 minus x plus 1 divided by 1 plus x? Let's add this up here because there is a pattern here. 1 plus x plus 1 minus x gives 2 in the numerator because minus x and plus x cancels out, divided by 1 minus x into 1 plus x, which is 1 minus x square. Again, we have 2 by 1 minus x square plus 2 by 1 plus x square. That now x square itself can be thought of as, let's say, y. So now it's 1 minus y, 1 plus y. It's 1 minus y square. So this is basically 1 minus x to the power 4. That's it, 1 minus x to the power 4. And on top, again, 1 plus x square will go multiplied by 2, and over here 2 into 1 plus x. So I will have 4 remaining. So it's 4 divided by 1 minus x to the power 4. And then the same pattern is repeated with the 1 plus x to the power 4 to get 1 minus x to the power 8 in the denominator and 8 in the numerator. That's it. Question 16. Let a comma b be any positive integers. Okay, so x is between 1 to 9, or actually even greater than, it's not single digit, is not mentioned. Any number 1, 2, 3, 4, 5, okay, 200, 150. B any positive integer, same. And x equal to 0 or 1. Okay, x is fixed. X is either 0 or 1. Then we have to look at the options here. We need to figure out which option is necessarily true, or D, none of the above is necessarily true. And there are two variants to each option, with x equal to 0 or x equal to 1. So we need to quickly calculate these values, left hand side and right hand side, placing x equal to 0 or x equal to 1 and checking for consistency. Is the equal to maintained in both cases, right? So first, let's take x equal to 0. A to the power 0, that's 1. B to the power 1 minus 0, or 1 minus x, that's b basically, is equal to x equal to 0, so a vanishes. 1 minus x, so that's again 1, equal to b. So b equal to b, great. And with x equal to 1. So now a stays, b becomes 0, so that's a equal to xa, so that's again a, plus 1 minus 1, now x equal to 1, so that's 0b, so that's terms gone, and I get a equal to a. Okay, then the first one is true. I think we found the answer. Thankfully it was the first option. Maybe they put it knowingly because there was no other way than to simulate it over here. But let's quickly check the second option to make sure that's wrong, right? So in the first case, x equal to 0, I will have a to the power 0, that's 1. B, basically b remaining, equal to a. So b equal to a can't be true because x equal to 0. So second one is wrong. C, a, again I have b remaining when x equal to 0, but I will have nothing remaining on the other side. I'll have b equal to 0. So a is definitely the correct answer. It didn't take too long to check it either, did it? Question number 17. There are 6 boxes numbered 1, 2, 3, 4, 5, 6. Each box is to be filled up with either a white or black ball in such a manner that at least one box contains a black ball and all the boxes containing black balls are consecutively numbered. Okay, let's look at those constraints and let's visualize the situation easily. See, by reading it didn't create any visualization. I need to go step by step. 6 boxes, 1, 2, 3, 4, 5, 6. Okay, 6 boxes. Each box is to be filled up with either a white or black ball. Okay. So I need to put one ball, either a black ball or a white ball, in these 6 boxes. Imagine 2 balls, white and black. I have to be told at least in such a manner that at least one box contains a black ball. So I know I can't make it 6 white balls. I have to have at least one black ball. Okay. And all the boxes containing black balls are consecutively numbered. And in how many ways can we then fill this up? Let's try and figure out the pattern. Again, starting from the simplest case possible. It's given to us at least one black ball needs to be there. Right? So I have, let's say, one black ball. And that means the remaining 5 boxes can be white balls. Okay. That's just one way of filling it up. Now, black ball in box number 1 versus black ball in box number 2 is different because there is only one black ball, and black ball in box number 3 is different from black ball in box number 2. So there are 6 ways in which I can arrange the black ball when taking only one black ball at a time. Okay, cool. Now, when I take 2 black balls at a time, I can't take 0. I have to start from 1. At max, I can take 6 black balls at a time and fill up all the boxes with black balls. And then there is just one way of arrangement. All 6 boxes black. All of them are black, so there is just one way. So now for 6, I know I'm going to get 1 for 6 black balls. For 1, I just got how many? 6. The next one, when I take 2 black balls, what happens is I can select the first one in 6 ways, and then the second one, there are 5 options left. I can select it in 5 ways. So that's 30. What just happened? 6 plus 6 was fine. Now suddenly 30. Because we multiplied by number of ways the second ball can be selected without keeping in mind the constraint that the second black ball has to be in a consecutively numbered box. What that means is, if I start from the beginning, when I put the first black ball in 1, I can only put the second black ball in 2. I can't put it in 3 or 4 or anywhere else. Only 2. There's just one case. When I put the first black ball in 2, I can put the second black ball in 3. When I put the first black ball in 5, I can put the second black ball in 6, and that's where it ends. Putting the black ball in 6 does not enable me to put the remaining black ball in 1. If this was a circular, if the boxes were arranged circularly, then that would happen, but not in this case. So, basically there are 5 positions that can be taken by black ball 1, which is from 1 to 5, and not position 6. That place has to be kept open for black ball 2. And so now in this case, there are 5 options. 6, then 5, then 4, then 3, then 2, then 1, which is the all 6 black balls, only one option. That's it. So that's 1 plus 2, 3, plus 3, 6, plus 4, 10, plus 5, 15, plus 6, 21. B, 21. Moving on to question number 18. This is rather easy because we just need to follow instructions. That's all they're checking here. Can you follow instructions correctly? X equal to 1, y equal to 2. Step 2. Replace x by xy. Xy is equal to 2 right now. X now becomes equal to 2. Replace y by y plus 1. Y is equal to 2 right now. Y becomes now 3. Okay. So x equal to 2, y equal to 3. If y equal to 5, which it is not yet, it is just 3, then go to step 6. Otherwise, go to step 5. Step 5 is nothing but go to step 2. So I need to repeat the same process again. So now I had 2 and 3. Right? Okay. So now xy is equal to 6. Now what will happen? Y will become 4. After 3 it will become 4. And x is now 6. Okay. I go back again to step 2. And now 6 into 4, xy is becoming 24. And y is becoming 5. Since it's 5, I get to stop. And b, the final value of x is xy because it got replaced by xy before operation 3 could be performed. Therefore, it is 6 into 4, 24. Question 19. In a stockpile of products produced by 3 machines M1, M2 and M3, 40% and 30% were manufactured by M1 and M2 respectively. What that means is the stockpile contains things produced by either M1 or M2 or M3. Nobody else has produced anything. So if you tell me 40% have been produced by M1 and 30% has been produced by M2, that means the remaining 100 minus 30 minus 40, which is another 30%, basically 70% is M1 and M2. That 30% is M3 produced. Realize in my quick words, I just used every form imaginable of representing that information so that it is visualized in all possible ways before I move on to the next statement. Because I don't know which visualization I'll need. 3% of the products of M1 are defective. Okay. So, of the products which are manufactured by M1, which is 40% of the total, 3% is defective. 1% of products of M2 are defective as well. Okay. Of the 40% manufactured by M1, of that 3% is defective. So that's 1.2% because 10% of 40 is 4, 1% of 40 is 0.4, 0.4 into 3, 1.2. 1.2% from the second, it's 1% of 30%, which is 0.3. Again, you can just go 10% of 30%, 3. 1% of that, 10% of 3.3. So you can easily get to that number. So 1.2 plus 0.3, 1.5% defective. Now, while 95% of the products of M3 are not defective, which means 5% are defective, 5% of the leftover 30%, so that's 1.5 added together, that's 3% total defective. What's the percentage of defective in the stockpile? As if they could ask any other question after doing these calculations. Answer is A, 3%. See, if people are leading you down a certain path, there are some questions in which it makes sense to start calculating during the question itself, because there is nothing else that they can ask once that is done. At max, they could have asked what is the percentage defective of products from 3. That's so simple, right? It's just 5%. They've already told 95%. It can't be that simple also. Maybe it can be, but as long as you visualize it correctly, as long as you do some of these calculations while reading along enough so that you can calculate everything, you know the values, you know what's missing, you know what's there, you'll be able to predict what question is going to be asked before you have even arrived at the question statement. And then you can move around according to what's been asked for even data sufficiency. Question 20. For any two numbers x and y, we define x star y, which is a custom function, equal to x plus 0.5y minus xy. Okay. Suppose that both x and y are greater than 0.5. Okay, we are told x and y are definitely greater than 0.5. Then x star x is less than y star y if. So we are asked what is the condition under which x star x will always be less than y star y. Let's look at it. What and the only number, if I look through the options, more than, greater than signs as the relationship, 1 is the absolute number that is used. So we know we need to check out 1. If we check out 1, we can put an x and y around it to quickly see if which of these relationships are coming out of numbers that we take. So what's x into x if we replace it in x into y, or sorry, x star x if we replace it in x star y? It's x plus 0.5x, so that's 1.5x minus x into x, so 1.5x minus x square. Notice here for x equal to 1, this value is equal to 1.5 minus 1, which is 0.5, it's a positive number. For x greater than 1, the moment let's say x becomes 2, what happens? 1.5 into 2 is 3 and minus 2 square is 4, so it becomes minus 1. So it changes sign the moment it crosses x equal to 2. We can see that, and when the sign change will happen, till before that everything is increasing. It's 0.5. If we increase slightly above 1, let's say we take 1.1, right? So 1.5 into 1.1, that's basically going to be 0.55 added to 1.1. So 1.65 minus x square, 1.1 whole square is basically 1.21. That's 11 and 121 with the decimals. 1.2, and it's still a positive number, right? And if you see the magnitude of the positive number, now it is 1.65 minus 1.21, which is basically 44, yeah, 0.44. It's come down from 0.5. So gradually it's going to keep decreasing until the number itself changes, right? From 0.5 it's going to keep going down up to 1. What's happening? Because we have been told x and y are both greater than 0.5. So if we figure out how x and y behave while going from 0.5 to 1, we know how x and y is going to behave. We know how x star x and y star y are going to behave after it crosses 1. In the fact that at 1, it is a positive difference of 0.5, positive value of 0.5. It keeps decreasing till it reaches 0, after which point the negative starts increasing. So now if I take x and y, based on what the numbers are, I'll be able to tell what kind of behavior it will have all throughout its range. So 0.5 to 1, what's happening? So let's say 0.6 in it and see, right? 0.6 for x star x is 1.5 into 0.6, which is 0.9. Okay, 0.9 plus, minus 0.6 whole square, which is 0.36. So 0.9 minus 0.36, which makes it 0.9 minus 0.36, 0.54 is what's remaining. So 0.54 at 0.6 value for x or y, it doesn't matter which one you take. At 0.6, x star x or any number star itself is equal to, at 0.6 is equal to 0.54. Now for 0.7, it's 1.5 into 0.7, so that's 1.05 minus 0.49, so that's 55 and 1.56. Okay. Now from 6 to 7, it just increased to 0.56 from 0.54. And at 1, it was how much? Just 0.5. At half, x equal to 0.5, what happens? 0.5 itself, 1.5 times is 0.75 minus 0.25. So that's 0.5. So between half and 1, it rises up from a value of 0.5, a value of 0.5, as x dot x is that much at 0.5. And even at 1, it comes back to 0.5. Only this time it's 1.5 minus 1. Okay. So it goes up, comes down, then keeps going forward, keeps decreasing up towards 0. So from 0.5 it increases to a certain maximum, then decreases back to 0.5 by the time it comes to x equal to 1 or y equal to 1. And then after that, the value of this function starts decreasing until it reaches 0 and keeps decreasing further into the negative. So now if x and y are both going to be greater than 0.5 always, what we are told is that, hey, x and y itself are always going to be positive numbers. Which of these four relations will enable me to have a circumstance under which x star x will always be less than y star y? We just discussed these situations. Let's look at them quickly and see which one fits the options. I know y star y in its behavior pattern. If, let's see the options. We have one case in which x and y are both less than 1 and y is less than x. I have one case in which y is greater than x and one case in which x is greater than y and both of them are less than 1. what will happen? Basically, the overall value of x star x will go up as the value of x goes up beyond 0.5. But after a certain point, it will start coming down as well. So the relationship while going up between x and y won't hold constant, because if x is less than y or greater than y, there will be individual points of maxima minima, and I can find any combination or try and find some combination in which this relationship doesn't hold. It's going up and down like this, 0.5 up down, 0.5, it's going up, and then coming back down to 0.5 again. I haven't figured out the maxima. We saw 0.6 wasn't it, we saw 0.7 wasn't it. It could be probably at 0.75 and then it goes down, something like that possibly. Anyways, so now if x is greater than 1, if any of these are greater than 1, what will happen is from 0.5 it will start decreasing, and it will keep decreasing and then reach 0, and then it will continue to become negative. So as if x star, for x star x to be less than y star y, I can probably create something like this, that x star x, which is the x part of it, if x is greater than, if x is always greater than 1, right? If x is always greater than 1, it is going to be at max 0.5. After that, it's going to start decreasing. We saw that, right? With 2, it was directly giving negative. With 1.1, it had 0.4 something. So it had started coming down. The quick 1.1 check again. 1.65 minus 1.21. Yeah, it's less than 0.5. So it had gone down. So for x greater than 1, it will always be less than 0.5. Okay, I have that in B, and y is always less than 1. So what will happen? Y will go up above 0.5 and come back down to 0.5 at 1 again, at y equal to 1. And we have been given here y is always going to be less than 1 over here, so y will now be constrained to being between 0.5 and 1. At y equal to 0.5, the answer is 0.5. At y equal to 1, the answer is again 0.5. And we have seen it increase beyond 0.5, decrease a bit. Maybe under some cases it will it ever go down below? This is an intelligent, interesting question. Will it ever go down below 0.5? Because if it never goes down below 0.5, we are safe. Completely safe. It can, we know B is then the right answer, because 1 will always be less than 0.5. At max it can be 0.5. So now if y is less than 1, what will happen? Let's say at 0.8. 0.8 into 1.5 is 1.2. 1.2 minus 0.64. 0.8 into 0.8. Whoa, what just happened? 0.64 plus 0.5 equal to 1.14, and that means 0.56. It went above 0.5. It went above that. So, okay. But x is greater than 1. So y went above 0.5. It is still above 0.5. It will come back down later, but yeah, B is definitely the right answer. We have checked it for 0.6, 0.7, 0.8. I was explaining through and taking time. You can quickly check it. These kind of things are stuff that you can quickly write down and check, because you can write down through pattern identification in a faster manner than thinking through it. But these are the thoughts that you need to have. I'm going to show you elegance of the method examination way of doing questions in the next question as well. Question 21. Consider a function fk defined for positive integers k equal to 1, 2 and so on, 3, 4, 5 presumably, and all the other positive numbers. The function satisfies the condition f of 1 plus f of 2 plus f of 3 plus ... is equal to p by p minus 1. Okay. Positive integers extend till infinity. That means this sum f of 1 plus f of 2 plus f of 3 is up to f of infinity. And that somehow comes back down to a fraction p by p minus 1. Where p itself is a fraction, where it is between 0 and 1. So what does this tell us? Let's plug it back. So fraction, let's say it's half. I'll get p by p minus 1 is half by half minus 1. That's half by minus half. That's minus 1. Okay. Suddenly I have minus 1. Okay. So this is a function that is defined for a positive integer. But when I add up all the summation of all these functions, it is converging, it is not diverging. Even though I am adding infinite number of numbers, they are slowly converging towards a singular number, which p could be any fraction. It could be half, it could be 1/3, 1/6, doesn't matter. But you are going to end up with a negative number because p minus 1 is going to be negative because p is smaller than 1. And it is a finite number. So that means this is a convergent series. Also, what the main thing of a series that we know is that every sequence in a series is dependent on the earlier term. That means there is a common way to express every term in a series. So the function f of 2 can be expressed in terms of f of 1, and f of 3 can be expressed in terms of f of 2 and f of 1 subsequently. Every term can be expressed in terms of each other. Now, they have told me then f of k is given by, we need to figure out which function it can be. Be careful, we can see a D, none of these options. So none of the three could be correct. But if it were to be one of the three, what would be its characteristics? We know it has to finally summate to a negative number. There are two ways. If f of 1 or if f of k is always positive, then it can never become, summation of it can never be negative. So f of k can be always negative, or it can be negative in a pattern such that every second number is negative, every third number is negative, or something like that. Now, what's the easiest pattern? Every number is negative. Let's look at the options given. P into 1 minus p, p into minus p to the power k minus 1, p into 1 minus p to the power k minus 1, p into 1 minus p whole to the power k minus 1. Notice over here, p is a positive number, 1 minus p will also be a positive number, k minus 1 is a positive number. It will never go negative. There is no room to go negative in option B and C. There is no point. It can only be in option 1 where you see there is a minus p term available which is going to change sign based on the exponent which is k minus 1. So what is going to happen? Every odd term, it will be positive. Every even term, it will be negative. So every second term is going to change sign. And because it's a decreasing function, it means that the subsequent number 1 and 2 together, f1 plus f2 together is a small minus quantity, and f3 plus f4 is a smaller minus quantity, such that it continuously adds up and finally ends up at minus 1. Something like, let's say, minus 0.5, minus 0.25, minus 0.125, minus 0.0625. The thing keeping on divided by 2, it will land up at minus 1. That's p by p minus 1 for p equal to half. And the way of expressing that f of k, any term of it, is basically, yes, p into minus p to the power k minus 1. That would be the perfect way, because p is the first term, and minus p to the power k minus 1, when k equal to 1, that term vanishes. Minus p to the power 0 is just 1, it's p, that's the first term. And then the next term for k equal to 2, it's minus p square. So 1 minus p square plus p cube minus p to the power 4 and so on. And that's basically the series A. Let's move on to the next question, question number 22. We are going to take a short break and take a pause.